Good morning, students. In the last video, we are discussing about the inverse trigonometric functions and some MCQ on the inverse trigonometric function. Today, let me continue the same lesson, that is the inverse trigonometric functions, which will come under the Karnataka CET and JEE main also. It will help you. Now, first one is that sine inverse of x minus x square by 2 plus x cube by 4 and so on, like this, plus cos inverse of x square minus x to the power of 4 by 2 plus x to the power of 6 by 2 and so on is equal to pi by 2. It means that we know one identity, sin inverse x plus cos inverse x is equal to pi by 2. Using that one, it means that if it is equal to pi by 2 means this both must be equal, is it? Then we have to find an x value here. Therefore, first I will, using that identity, I will write x minus x square by 2 plus x to the power of 3 by 4 and minus and so on is equal to x square minus x to the power of 4 by 2 plus x to the power of 6 by 4 minus and so on. For what value of this x the both are equal, we have to verify 1 by 2 1 like this. Just I will better to take a 1 is first. Okay, now afterwards you can go for other thing. X is 1 minus 1 by 2 plus 1 by 4 minus and so on 1 minus 1 by 2 plus 1 by 4. S for the x, when I put an x value is 1, both are equal. 1 minus 1 by 2 1 also. Then x value is equal to what? 1. This is second option is the right one. Let you move on to the next one. Next one, second one. Sine of 2 sine inverse root 63 by 65. What is the value of this one? They are asking. Now in this case, I will take this as a theta. Sine inverse root 63 by 65. This one. Okay, as n is equal to theta. Now root 63 by 65 is equal to sine theta. Now in this case, cos theta, what we can write? Cos theta is equal to sin theta is equal to x, means cos theta is equal to what we can write? Root 1 minus x square. First I gave 1 minus x square, that is a 63 by 65. It is nothing but what? 65 minus 63. Root 2 by 65. Cos theta. Okay, na? Sin theta is equal to x, means cos theta is equal to root 1 minus x square. Okay, na? That's what I am using, that identity I wrote here. Now I will take this value sin to this value I took as a theta. Okay, na? What is the sin 2 theta? 2 sin theta into cos theta. Then 2, what is the sin theta value is root 63 by 65 into root 2 by 65. Now what I will do here, that is 2 as it is, root 63 into root 2 is what? Root 126. Then root 65 into root 65. Okay, now 2 root 126 by 65. Which option? Fourth one. Let me move on to the next one. Okay, next one is the value of the expression sine of cot inverse of cos of tan inverse 1 is. What is the value of that one? They are asking. Okay, na? It is sine of cot inverse of cos of tan inverse 1 is what? Tan inverse 1 is 45 pi by 4. Then sine of cot inverse cos 45 value is 1 by root 2. 9. Now sine of cot inverse 1 by root 2, I will write 1 by root 2. I know. I don't know the value of the cot inverse of 1 by root 2. Then I will take a right angle triangle, that is cot inverse nothing but which side? Adjacent 1 opposite to root 2. If it is using the Pythagoras, 1 square to root 2 square 2 1 to root 3. Value is root 3. Now sine of sine of cot inverse in terms of sine inverse. Sine inverse opposite root 2 by root 3, hypotenuse root 3. Okay na? Sine inverse of this one is a root 2 by root 3. Which option? This one. That is, we can write it as a root 2 by 3. This option is right. Okay, understood? Let me move on to the next one. Okay, next one. Tan inverse of 1 by 3 plus tan inverse of 1 by 7 plus tan inverse of 1 by 30 and so on. Tan inverse of 1 by n square plus n plus 1 plus up to infinity is equal to what they are asking. Now I will take an n term. Okay, now I will simplify what is the nth term. It is not possible to predict what is an n term here. I will try to simplify that one. Tan inverse of 1 by n square plus n plus 1 is equal to, here tan inverse, here I will add and subtract n plus 1 minus n plus 1 minus 1. I add the plus n, subtract the minus n. Same way here 1 first I will write 1 plus, in these two n I will take common, n into n plus 1. This is how it is a tan inverse a minus b by 1 plus a into b. It nothing but an tan inverse n plus 1. Here minus is like minus tan inverse n. Tan inverse a minus tan inverse b formula. Okay na? Tan inverse n plus 1 minus n by 1 plus n plus 1 into n. Okay, that is it. Now I can predict an nth term, how the terms are. How first if I fill the value is tan inverse 2 minus tan inverse 1 plus tan inverse 2 minus tan inverse 3 minus tan inverse 2, like this and so on. What we will get? Plus tan inverse n plus 1 minus tan inverse n, you will get it and so on. Now tan inverse 2 minus tan inverse 2, tan inverse is like that, it will get cancelled. Which is left? Here tan inverse as a tan inverse n also will get cancelled. Now we will be left with these two finally. Then tan inverse n plus 1 minus tan inverse 1. Okay, now this is up to which term? Up to infinity is there. That's why limit n tends to infinity. Okay, now tan inverse infinity. What is the tan? Infinity plus 1 is infinity. Tan inverse infinity is what? Pi by 2. Tan pi by 2 is infinity. Minus tan inverse 1 is a pi by 2. Pi by 4. 45. Then 90 minus 45 is a 45. Pi by 4. Which option? 5 by 4. Okay, na? Be careful, it is very important example. Let me move to the next one. Okay. Okay, next one. The value of sine inverse 1 by 3 plus secant inverse 3 plus cos of tan inverse 1 by 2 plus tan inverse 2 is what they are asking. Okay. Now, here what we can write here, this one sine of sine inverse 1 by 3 plus, yes, second inverse, reciprocal is what? Cos inverse 1 by root 3. Okay na? Plus cos of tan inverse 1 by 2 as it is, reciprocal of tan inverse 2 is cot inverse 1 by 2. Now this becomes sine of sine inverse x plus cos inverse x is equal to pi by 2 plus cos of tan inverse 1 by 2 cot inverse 1 by 2 is a pi by 2. Then what is the value? It is a tan 91, tan 0, that is a 1. 1 plus 0 is what? 1. It is the first option. Okay na? Okay students. Now up to here I try to cover all the types of MCQ in the inverse trigonometric functions. Okay na? next class, next video, we will discuss about the next lesson. I think matrices. We will continue in the next class. Okay. Thank you so much. We will meet in the next class. Bye. Take care.